This is Abha Gautam and I welcome you all to Ganesh Institute. Now, in this video, we are taking up some of the introduction topics from matrix, its types, and transpose of a matrix. Okay, so what do you mean by matrix? Let's begin. Here, when matrix is a kind of an arrangement of elements. So, if you see horizontal numbers are placed in rows, and if we place numbers vertically, we call them columns. Now, let's say we have a mathematical representation of this sort, right? Enclosed in a square closed parenthesis. So this is a matrix. Here you will see that all these numbers are elements. These are called elements. And if you have to tell the position of these elements, so just see this 2 is in the first row and first column, so we can write it as A11. So A11 means first row, first column is 2, and then here it is A12, A13. So thereafter 21, 22, 23, that means second row, first column, right? Then 3-1 is third row first column, 3-2, 3-3. So you will see that here there are 3 rows and 3 columns. So the order is 3 by 3. Order represents number of elements, how many in rows and how many in columns. Okay. So this is matrix. Now if we talk about the types of matrix, what are they? Let's see them. Here you can see that in types of matrix we have a huge range, right? Zero matrix, square matrix, identity matrix, diagonal matrix, symmetric matrix, triangular, symmetric, skew-symmetric, and augmented. So let's take a one by one all of these. First, zero matrix. So it is the matrix, as the name suggests, all the elements are zero. So if we talk about 2 by 2 order, so both rows and columns have all the elements as 0. So this is a zero matrix. Now if you talk about square matrix, see, if I have to mention a matrix of order 2 by 3, that means there are 2 rows and 3 columns. What kind of matrix it is? See, if it has only 2 rows, that means the elements are having arrangement like A11, A12, A13. Why? Because there are 3 columns, right? And then A21, A22, A23. What are these? Only 2 rows and 3 columns, right? But this doesn't seem like a square, right? It is like a rectangle. So when we say square matrix, that means all the rows and columns, the number of rows and number of columns are same, are equal. That means a matrix of order 2 by 2, 3 by 3, 4 by 4, that means in general n by n order, right? So there is a time lapse while I'm writing and it is showing something else. Okay, just bear with me. So this is a square matrix, right? So this one is of 2 by 2 order and it is a square matrix. Now, if I ask you what is an identity matrix? So identity, see, in a matrix, if you write it like, let us take an example of 3 by 3 matrix, okay? So I'm writing down the general elements. right? So this is a 3 by 3 order matrix. Now, if I ask you what are the diagonal elements, so these three are one set of diagonal elements, and another diagonal we can say this one, right? Just bear with me, this one, right? Now, this A11, A22, and A33 are main diagonal elements. This is the main diagonal. Okay. What are the elements which are involved in it? A11, A22, and A33. So when you have to mention identity matrix, how will you identify it? All the main diagonal elements should be unity, should be 1, and rest of all the elements should be 0. That means if I have to mention the identity matrix of order 2, that means 2 rows and 2 columns, then how I will write it? So main diagonal elements, the elements should be 1, right? And rest of the elements should be 0, correct? So this is the matrix of order 2 by 2, and because main diagonal elements are 1, therefore it is an identity matrix of order 2 by 2. If I have to mention identity matrix of order 3 by 3, then all the main diagonal elements will be 1, rest all will be 0, all other, right? Now if we talk about diagonal matrix, so I can also write this identity matrix as I3. I3 means an identity matrix of order 3 by 3, right? Now if we talk about diagonal matrix, so it is also somewhat similar with this identity matrix. The difference is you have to, there is not necessarily all the elements in the diagonal form 1. So let's say we have 4, 5, 6. Main diagonal elements should be non-zero, rest all must be 0. Okay, so the slight difference between identity matrix and diagonal matrix is that in identity matrix you have all the non-zero elements in the main diagonal form as 1 only, whereas in diagonal matrix you have all the non-zero elements in the main diagonal form, rest all the elements are 0, correct? Now if we have to talk about the triangular matrix, so as the name suggests, it must be having some triangle form, right? So yes, it is a matrix which forms a triangular shape, but in this form. So let's take up an example. If I am, just bear with me, if I am writing it like, I'm taking up another example of 3 by 3 order. So 1, 2, 3, 4, 5, 6, right? Rest I am taking these 3 elements as 0. So because this matrix has a triangular shape of non-zero elements, so this is upper triangular matrix. Okay. Now if you talk about lower triangular matrix, so can you guess what will be the elements look like? So in that thing, it will be in the form of 1, 2, 3, 4, 5, 6. Rest upper elements will be 0, right? So you can see this is a lower triangular matrix. You don't need to draw this triangle. I'm just telling you how it looks like so that you can relate with the image. Okay, so triangular matrix, I hope it is clear. Now for symmetric and skew-symmetric, let's talk about the transpose. Okay, so for that, let's just bear with me. Now, in order to understand about symmetric and skew-symmetric matrix, let's talk about transpose first. So what do you mean by transpose? So in a matrix, you have rows and columns, right? The order represent rows by columns. If you interchange the rows with columns, that means, let's say, if your new matrix will have order n by n instead of m by n, then that matrix will be regarded as transpose. If this is A matrix, then its transpose will be A raised to power t or A dash. Okay, so let's figure out if I have example 1, 2, 3, 4, 5, 6 as a matrix of order 2 by 3. Why 2 by 3? Because there are 2 rows and 2 columns, right? Now, if this is the matrix and you have to find out the transpose, then firstly figure out what should be the order or what will be the order for that matrix. So here it is 2 by 3, so it will become 3 by 2, right? That means 3 rows and 2 columns. So you can see here the first row is 1, 2, 3. It will become the column. Then second row is 4, 5, 6. That will become second column. And in this way we have 3 rows and 2 columns. So this is the transpose. Now let's come back to that topic where we were talking about symmetric and skew-symmetric matrix. So when we talk about symmetric, then the transpose is equal to the matrix itself. And when we say a matrix is a skew-symmetric matrix, that means the transpose is equal to minus of that matrix. Okay, so let's figure out how we can say so. Let's say you have a matrix having elements as 1, 2, 3, 4, 5 and 6. So if you have to find out the transpose, what it will be? So this is first row, make it first column. This is second row, 2, 4, 5, make it second column. Then third row is 3, 5, 6, make it third column, which is 3, 5, 6. But you can see that these elements are exactly same as that are given in the matrix A. That means this is a symmetric matrix. Whereas if you want to have an example of skew-symmetric matrix, then do the transpose. If the transpose, if you take out minus as common, if the transpose is equal to minus of that matrix, then it will be a skew-symmetric matrix, right? Now let's talk about the augmented matrix. Now if we talk about augmented matrix, then what it is? Let's say you have a set of linear equations and you are supposed to solve it. Though we are not solving it here, but still let's say you have ax plus by equals c and you have dx plus ey equals f. So this is a set of linear equation you're having. Now you can see there are two variables. Now try to make a matrix in the form of ax is equals to b, where your A is a matrix which you will create with the help of these coefficients. So here the coefficient of x is A, here the coefficient of y is b, then in another equation coefficient of x is d, and here in the coefficient is e, right? So this is the matrix of coefficient, right? Then you have x, which is the coefficient of variables, the matrix of coefficient of variables. That means it will be having x and y. Then you have b, another matrix, which is the coefficient of constants, the matrix of coefficient of constants. That means it will be having c and f. right? So if you will write it not by having this equal sign, in fact, a matrix together having these A, B, D, E all together, okay? This A matrix and then these constant matrix and just separate it by one pi. So this is clearly a matrix of coefficients. This is clearly the matrix of constants, coefficient of constants. Or you can say just constants. Coefficient is not there with constants. Anyways, so this is the type of augmented matrix which we use at many places, like to have that Euclidean form, to solve Gaussian equation. We have many applications of this type of augmented matrix. But I'm hoping how you will create this augmented matrix, you got it right. So these in this video we have discussed about the types of matrix, what is a matrix, then types of matrix, then transpose and augmented matrix. I'm hoping that it is very clear all the concepts which we discussed, and if so, then don't forget to like, share and subscribe our channel. Till our next video, take care of yourself. Bye bye.